In the previous video, we learned about different index rules. Their product rule, quotient rule, zero index rule, negative index rule, and the power of a power rule. In this video, we're going to focus on some of the examples that uses the index rules. Okay, the first one is simplify a to the power minus 4 times a to the power 3. Okay, so we can attempt this question in two different ways, and I'll show you two different methods, and you can choose whichever method is making more sense to you. Okay, so in this one, so this is of the form of a to the power m times a to the power n, even though m is a negative index. Okay, so this is nothing but a to the power m plus n using the product rule. Okay, so this is then a to the power minus 4 plus 3. Now you all know what is minus 4 plus 3 is. It's minus 1. So that's equals a to the power minus 1. And if you don't want to express this answer in the negative index, you can inverse this one because we have the negative index rule. A to the power minus n equals 1 on a to the power n. So using that one, you can write it as 1 on a to the power 1. But if its the power is 1, you don't have to write that one. So the answer for this one is 1 on a. Okay, you can approach the same question using slightly different method. Using the negative index rule, you can write a to the power minus 4 as 1 on a to the power 4. Okay, so that's a to the power minus n equals 1 on a to the power n, and times a to the power 3. So this can then be written as a to the power 3 on a to the power 4. So this is now in the quotient form, and for the quotients, the rule is a to the power m on a to the power n equals a to the power m minus n. So using that one, this becomes a to the power 3 minus 4, and that equals a to the power minus 1. Same as before, 1 on a. Different method, same answer. You can choose whichever method is making most sense to you. Okay, now let's do another question. Simplify 2x to the power 4 y to the power minus 2 times 5x to the power minus 2 times y to the power minus 5. So, if you look at this question, you can see that there are two different variables, x and y. The index rules, all of the rules applies if the bases are the same. Okay, so we can only apply the multiplication rule for the same base. You can simplify these two x terms together, and you can simplify these y's together. Okay, and we cannot do anything to the x and y together. Okay, let's do that one now. So 2 times, the first thing you can do is multiply these numbers together, which you can do because everything is multiplied together. So it's 2 times 5 is 10. And x to the power 4 and x to the power minus 2 can be simplified together because they are multiplied each other. So x to the power 4 plus minus 2. Okay, I'm just putting a bracket to make sure it's adding minus 2. And then times y to the power minus 2 plus minus 5. Okay, so this is then 10 to the power 10, x to the power 4 plus minus 2 is 2, and times, so because it's a times, you don't have to write times in here, so it's simple, you can leave writing. So y to the power minus 2 plus minus 5, two negative numbers, it's minus 7. Okay, so that's the answer, 10x to the power 2 times y to the power minus 7. There's no simplification possible. Okay, now if you want to express this answer in terms of only positive indices, you need to get rid of this minus 7 in here using the negative index rule. The negative index rule is saying a to the power minus n equals 1 on a to the power n. Okay, using that rule, you can write the same answer as 10x squared on y to the power minus 7 taken to the denominator, it's y to the power 7. Okay, so that's the answer for this question. Okay, now let's do another question, simplify this whole term. Okay, so this can be approached in many different ways, and I strongly encourage you to pause the video and attempt this question yourself before you watch the solution. Okay. So I'm going to approach this question by simplifying the terms within the brackets first and then taking the powers of each terms. Okay. So to simplify this term, within the bracket p to the power 3 on p to the power minus 5, we can use the quotient rule. The quotient rule is saying a to the power m on a to the power n equals a to the power m minus n. Using that one, the term within the bracket becomes p to the power 3, m is 3, minus 5. There's two negatives coming, so that's a plus 5. Okay, and to the power 2. And that times p to the power 5 minus 2. So that's when you apply this quotient rule, and to the power minus 3. Okay, now let's simplify the terms within the brackets. That's a p, 5 plus 3 is 8 to the power 2 times p to the power 5 minus 2 is p to the power 3 to the power minus 3. Okay, now that's down to a very simple expression now. So we can further simplify this one by applying the power rule, because this is of the form p to the power 8 whole to the power 2 is of the form a to the power m to the power n. The answer is a to the power m times n. So using that one, we're going to simplify this one as p to the power 8 times 2 is 16, and times p to the power 3 minus 3 times minus 3 is minus 9. Okay, now look at that one. This is the product of two in the index terms. So it's a p to the power 16 times p to the power minus 9 is of the form a to the power m times a to the power n. So it's a to the power m plus n. Okay, so that's a p to the power 16 plus minus 9. So that's, the answer is p to the power 7. Okay, 16 plus 9 minus 9 is 7. So the answer is p to the power 7 for this question. Okay, I hope these 3 examples make sense to you. So I'll strongly encourage you to do as many examples as you can to master these index rules.